All right, guys, this is the last lesson before the quiz. It's talking about zeros of polynomial functions. So we've talked before about the degree tells you how many zeros it can have. Does that sound familiar? The degree 5 means it could have as many as 5 zeros and as many as 4 turning points, yes? Okay. So today we're going to find real zeros and polynomial, all the complex zeros. In other words, all the zeros of the polynomial. Okay. This is the learning targets for 2.4. There's a lot of stuff. Okay. It says you can generate the list of all possible rational. What does rational mean? Can be written as a fraction. Okay. So that would include whole numbers and fractions, decimals at end, decimals at repeat, all can be written as rational. I can find the real zeros by dividing. I can find complex zeros. You might have to do quadratic at the end to find complex zeros. I can write a polynomial in factored form with either prime factors or linear factors. And then I can, given the zeros, I can write the polynomial in factored or standard form. Lots of stuff going on today. Okay, the rational zero theorem. This is an easy concept, but students forget one little thing, okay? It says, can describe how the leading coefficient and the constant can be used to generate a list of all possible rational zeros. All right, so if you have a polynomial function, it says a polynomial function with every rational zero comes from the list of P over Q, where P and Q have no common factors, blah, 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 blah. Where do P and Q come from, Hofbauer? Okay, well, P comes from the factors of the constant, and Q comes from all the factors of the leading coefficient. What am I talking about? Well, this is what it looks like on your sheet. Yes, you have this on your notes, okay? Plus or minus all the factors of the constant over the factors of the leading coefficient. So you're going to have to generate a list. This is the example on your sheet. What is the constant? -6. Okay, so we have plus or minus 6. All the factors of 6 over the leading coefficient, which is 1. Well, what are the factors of 6? Besides 6, what else goes in there? 2, 3, and 1. Yes? So we write out all those factors over plus or minus 1, and you basically get 1, -1, 2, -2, 3, -3, 6, -6. Okay? 8 possible factors. I am not going to make you write them all out with plus or minus and separated by commas and all that fun stuff, but you're going to have to write out the list, not just the factors. In other words, I'll explain that better in a second. All right. Then it says determine which, if any, are zeros. What are the ways we could do that? We could plug them in to the actual function, right? See which ones gave us zeros. Anything else? Synthetic division, we could divide them in and see which one gives us zeros. We could graph it and just do trace and see which ones are zeros, yes? All of those are possibilities, okay? Now, this particular one, it says -2 worked, and they did synthetic division, and the depressed polynomial was this. Everybody okay? It says, now, does this factor? No, so what do we get to do now? Quadratic formula to find the 2 irrational roots. So there's 1 at -2, and we have to do quadratic formula. Okay? So opposite of b, plus or minus the square root of b squared minus 4 times a times c. Ooh, that negative kills some of you every time. this is going to become plus positive, right? Those are supposed to be multiplication. Looks like a decimal. 12 and 49. Is that 61? Anybody typing for me? Is that right? Okay. So 7 plus the square root of 61 over 2 and 7 minus the square root of 61 over 2. You can leave it plus or minus. I don't care. Did we find all three zeros of that function? Okay. Anybody lost? Question? We're good? All right, so we're supposed to list all the possibilities. I don't know if you have this or not. Do you have this on your paper to write these down? Okay. So it's plus or minus the factors of the constant over the leading coefficient. Let me write that down one more time, okay? So it's plus or minus all the factors of what? 36 is the constant, yes? Do you not have this one? Okay. Oh, just help me out then. What are the factors of 36? 1 goes in, 2 goes in. You don't have to do them in any particular order. I'm just trying to. 6, and then 6 went in 6 times, 4 went in 9 times, 3 went in, 12 times, 2 went in, and 1 went in. All over the factors of 2, which are? Okay. If this was a quiz, and I'm not going to put this on there because it's more than I want to grade, the list would look like this. 1, 2, 3, 4, 6, 9, 12, 18, 36. What else? All those over 2, yes? Okay, so 1/2. What else? We already have that on the list. 2 over 2 is 1. It's on the list. 3/2. 4 over 2 is 2. Already on the list. 6/2 is 3. It's already on the list. 9/2. Then are the rest on the list? Okay. Now, like I said, I don't think I'm putting that on the next quiz because I don't want to grade that and someone will miss one and I'm going to feel really bad giving you a bad grade for that, right? But that's how you have to list them. Okay? You can write plus or minus once, but I need the list of all the possibilities. Do you understand? You can't just leave it like this. Okay. So you have this one. What are the list for this over 1 plus or minus the factors of 20 over 1, which are just going to be what? 10 and 20? 1, 2, 4, 5, 10, and 20. There's nothing else to divide by but 1, so here's our list. Okay, to save time, I graphed it for you. You would type it in and graph it. What do you think is working by the looks of this picture? Can you see anything there, guys? Whoa. It looks like it. Okay, how do we test? Besides graphing it, let's review what we did yesterday. We think -2 works, so I'm going to do synthetic division. We're going to do, remember, if we're trying to find all the zeros or the factors, we can do successive division. Does this sound right? Do one after the other, okay? So we have 1, -5, -4, and 20. What did I do? We're good? I'm thinking we're trying this one at -2, right? Okay, bring down the 1, multiply, add, multiply, add, multiply, add. Was it a 0? Okay. Let's try, what else do we think? Now this actually would probably factor, but let's just keep going because I want to practice successive division. So do you think +2 is also 1? So I'm going to do +2, bring down, multiply, add, multiply, add. Okay, yesterday it would have said write as factors. We'd have x plus 2, x minus 2, and what is this leftover piece right here? x minus 5. Those are the factors, but today it said find the zeros. What are the zeros? Okay. Could we have graphed that and just tested all three of them? Yep. I just want to make sure you remember the successive division piece. Question? You guys rock. Okay, fundamental theorem of algebra says that if you have a polynomial of degree n, so the degree, then it has at least one zero, real or imaginary, in the complex number system. A polynomial of n degree has exactly n zeros, including repeated zeros in the complex number system. Do you remember when we talked about complex numbers? There's imaginary and complex. Does anybody remember the difference? Yes, complex numbers includes real and imaginary. Like, remember it was like a plus bi form, but it could even have no imaginary part. It could just be the real number part. So if you include real and imaginary, which becomes complex, then the degree tells you how many zeros it has. Why are we even talking about this? Well, when we do this, this was degree 3. Did it have 3 real zeros? No, but if we can find this one, divide it out, what's going to be left is a degree 2. Can we find the imaginary zeros from quadratic formula? Lucky us. We can. Okay. The conjugate root theorem. Oh, this is not going to be your favorite idea, but it's not complicated. If you have a imaginary or irrational zero, then its complex conjugate, or its conjugate, is also a zero. You can't have a zero of 3i without a zero of negative 3i. You can't have a zero of 2 plus 3i without a zero of 2 minus 3i. As long as everything in the polynomial had real coefficients, rational coefficients, okay? And the same goes for this. If you have 2 plus the square root of 6, you have to have 2 minus the square root of 6. They come in conjugate pairs. Does that sound familiar? Maybe? Okay, so the fundamental theorem of algebra, again, states it has as many zeros as the degree, but that can include repeated zeros. What are repeated zeros? Like multiplicity 3, okay? Then you would count all 3 of those as 3 zeros. All right, the conjugate theorem says if a plus bi is a 0, then a minus bi is also a 0. Okay, here we go. Write a polynomial function of least degree with real coefficients in standard form that has 0 and square root of 2i as zeros. All right, so we have a 0 at 0. And then it says the square root of 2 times I, and the I is not under the radical. I'm going to write it out front because otherwise mine will look like it's under the radical. Is that all the zeros right there? What did we just learn? If I square root of 2, then negative I square root of 2 has to be a 0, the conjugate. All right. We are supposed to write a polynomial function of least degree. Ugh. Okay, what does this make a factor? X, yes? What would this make a factor? Okay, if 2 is a 0, then what's the factor? X minus 2, yes? Okay, so if this is a 0, then x minus I square root of 2 is a factor. Don't have to do anything else with it yet. Does that seem okay? It says down here a factor is always x minus c, where c is the 0. So what is this going to look like? Yes, x minus negative I square root of 2 will become plus I square root of 2. Okay, we're halfway there. What does it say though? Standard form, and guys, I am not going to be requiring standard form, but I am going to require this. Do we have all real coefficients in this problem yet? No. Okay. To make this real, we need to FOIL this together. Okay, so there's an x out front. I'm just going to leave the x out front. What do we have here? X times x is x squared. X times I square root of 2 would be x times I square root of 2. This right here is going to be, it's the whole thing with conjugates. What's going to happen? Minus x I square root of 2. Yes, those are going to cancel out. That was the whole point. And then last times last. Okay, we're multiplying this times this. Be careful. Minus I squared times 2. Right? I times I is I squared. Square root of 2 times square root of 2 is 2. What does that become? Yes, because I squared is negative 1. Negative 1 times negative 2 would be plus 2. What happens in the middle here? Yep, so we end up with an x times an x squared plus 2, which standard form would then be x cubed plus 2x. I'm going to let you stop as soon as you have real coefficients. You don't have to FOIL it all out. This one, it wouldn't have been hard, but some of them it would be. Okay? Okay, I'm going to move this. Is that what you have on your paper? X cubed plus 2x? It was all done for you, right? Okay. All right, you're going to want to kill me. I'm just saying. All right, find all complex zeros of this given that 2 plus I is one of the zeros. If 2 plus I is one of the zeros, what else is also a zero? 2 minus I. 2 plus I, 2 minus I are zeros. Okay? What if we graphed this? Could we see if there's more zeros we can find? What are all the possible rational zeros? Can somebody help me write the list? 1, 2. We're doing factors of 30. Yes, guys? 5, 6. Now 3 goes in there 10 times. 2 goes in there 15. And 30. Okay. Those are all the nice ones. Anybody graphing finding any for us? Negative 2 and positive 3 seem to work. Okay. Oh, they want us to do, oh, I wrote on here we should do long division. Okay. If 2 plus I is a 0, then x minus 2 plus I is a 0. Does that make, is a factor? Everybody okay? If 2 minus I is a 0, then x minus 2 minus I is a factor. Can I write those without so many parentheses? Could you distribute the negative for me? This becomes what? 2 minus I. And this one? X minus 2 plus I. Okay. What this is asking us to do right here, don't shoot me, is to FOIL those two things together. Whoops, that's an I back there. All right. I'm going to do this. And you can just watch if you want. I'm going to distribute the x through this whole second parenthesis. It'll become x squared minus 2x plus ix. Does that seem okay? Then I'm going to distribute the negative 2 through that whole second parenthesis. Don't know that person at all. Wrong room, maybe. I'm 126, yes. I don't have an angel anything. All right. Distributing a negative 2 through here. Okay. I'm going to write it under like terms. Just this is a little hint. -2 times -2 is 4, right? Which doesn't add with anything that I've already written. But oh, I missed one. Okay, -2 times x is another -2x. -2 times -2 is a 4. -2 times I is a -2i. Okay, I did that in a weird order, sorry. Wrong name? Where? Yes. He needs to go to, is it out? Okay. Okay. He goes, you need to go pick your early up out in student services after this class. That makes sense. Okay. Thank you. All right. You're okay. I'm going to go and distribute this one real quick. I get a -ix, which I just wrote there because it matches up with this one, guys. Then I get a -2 times -i, which would be +2i. And then I get a -i times an I, which would be what? -i squared, which would become +1. I'm going to write it under this one. So what happens when I combine all those like terms? Those drop out. Those drop out. I have x squared. What is this? -4x. And back here I have +5. Then they suggest we do long division to find the other two, just to practice fun. We already graphed it. Did they work? Did somebody test them? Are -2 and 3 working? Okay. So the 4 zeros are 2 plus I, 2 minus I, -2, and +3. So the factors are x minus 2 minus I, x minus 2 plus I, and what are the other two from these? X plus 2 and x minus 3. Now, I need to explain the difference between that and this. Okay, because all of these factors have x only, these are called the linear factors. Okay, when it says find the linear factorization, you have to keep going until you have x's only. This is, we'll say prime, if you can leave it as prime factors, because this does not factor further, right? No, it doesn't, because its zeros are 2 plus I and 2 minus I. Okay? That's the difference in those. All right. Let's try this. Write a polynomial function of least degree with real coefficients in standard form. Factored form is great, but you have to have integer coefficients. Okay. -4, what's a factor? X plus 4. 1. X minus 1. Okay, 4 plus I. X minus 4 plus I, and we're going to distribute that in a minute. Now, if 4 plus I is a 0, what else is a 0? 4 minus I. And what will that look like when we write it as a factor? X minus 4 minus I. Okay. Now, it says we can leave it factored. Yay! X plus 4, x minus 1. That doesn't say x minus 1. But can we leave this mess? Why not? It says integer coefficient. Yes, because it's gross is what I'm telling you. Because it says integer coefficients is why. All right, let's get rid of the extra parentheses. X what? Minus 4 minus I. And this one? Minus 4 plus I. Okay, ready for some fun distributing? Do you want to do it in one big long line, or do you want to try to line them up like I did? Big long line? Okay. So distribute the x through the second parenthesis. We'll have what? I'm doing this one into all of this. Minus 4x plus ix, okay? Got that one done. Now I'm going to do the negative 4 into that second parenthesis. What do I get? Minus 4x plus 16 minus 4i. Okay, got that one done. Now a negative I through that second parenthesis. Plus 4i minus I squared. Okay. What is minus I squared, first of all? That's a positive 1, right? Okay, there's a minus 4i and a plus 4i. There's a minus ix and a plus ix. That's the whole point of doing this, is we're supposed to get rid of all the i's. So what's left to combine? X squared, a total of minus 8x. What else? Yes, there was a 16 and a back there a plus 1 is 17. 17. Yeah. Thank you. Everybody okay? Now, that's horrible, yes? It's a pain in the neck. Okay. I want to teach you a shortcut. Okay? When I have something like this, how did you learn to factor that? They have to multiply to make 8, yes? But add to make this. Multiply and add. Multiply and add. What's the word for multiply? And the word for sum? Okay. This is what I want you to think about for a minute. Look back up here to my example. Factor this. It factors x minus 2x minus 4, right? I said that backwards, but it factors. What are the zeros? 4 and 2. If I multiply those zeros, what do I get? 8. If I add those zeros, I get 6. Does that go back here? It does, except this one had to be the opposite of the sum, yes? That's always true. The zeros added together and change the sign will give you this term in front of the x. The product will give you the sum at the, or the product will give you the number at the end. So let's do the one we just did. The zeros were 4 plus I and 4 minus I, yes? Okay. Can you add those together? Do you remember your complex numbers? What happens when you add those together? You get 8, yes? Now multiplying them is a little bit trickier, but it's not that bad. What happens? Yes, we FOIL. We get 4 times 4 is, in the middle two terms do what? Cancel out, and then we have a minus I squared, which becomes plus 1, which is 17. So did we end up with x squared minus 8x plus 17 when we did all that jazz a minute ago? Right here. Okay? So this is the shortcut. It's minus the sum and plus the product if you want to do it. Is there another example for us? We got time. Let's do a quick one. What if the zeros were 7, negative 3, and 4 plus I? Okay, write the factors. Guys, this means what's a factor? X minus 7. This means x plus 3. Now, before we go any further, what is the other 0? 4 minus I. Okay, rather than write this out and FOIL it all together, okay, we can use the rule we just did, the sum and product. What does the sum and product mean? The sum means you add them together. What is 4 plus I plus 4 minus I? Okay, now we need a product. 4 times 4 is 16, plus 4i and minus 4i, gone. Minus I times I would be minus I squared, which is plus 1, which is 17. Did I just make up the same question we just did? Oh my goodness. Okay, so what happens when you flow it together? It's x squared minus the sum plus the product. Okay, let me see if I can do a little bit better on one. I'm going to start. We've already figured out that it had x minus 2 and x plus 1 and an x minus 3. I have no idea. But it's got these two zeros at 1 plus 2i, and the other one would then be at 1 minus 2i. Okay, so it's got x squared. What is the sum of these two terms right here? 1 plus 2i plus 1 minus 2i would be, okay, I'll put a little plus in there. 1 plus 2i plus 1 minus 2i would be 2. The product, okay, 1 times 1 is 1, plus 2i minus 2i is gone, minus 4i squared, which becomes 4 plus this 1 is 5. So we get what? Minus 2, the sum, plus 5. All right. You don't have to know that rule. You can just FOIL them out for a good time. Okay. In example 6, guys, you wrote a function with real and complex zeros. A function has complex zeros when its factored form contains a quadratic that is irreducible. Okay. So every polynomial function of degree n with real coefficients can be written as a product of linear factors and irreducible quadratic factors. We already talked about this. It's prime. All right. So this is what they're going to want you to do. They're going to want you to write this function as the product of linear and irreducible factors, then as the product of linear factors, and list all its zeros. All right, here we go. So the first thing you're going to do always on these problems is graph, unless you want to try all the factors of 216. Not so fun. So we graph. This is what I found from the graph, okay? I found it had a 0 at -6 and a 0 at 4. I'm not taking time. Everybody knows how to find those, right? I'd rather spend the time on the problem than waiting for you to graph it. Okay. So we know that's actually part of C. It has a 0 at -6 and a 0 at 4. But it says right as a product of, okay, how are we going to find how that works out? Ideas what we got to do next? Yes. We have to do synthetic division. Doesn't matter which one you do first. I could prove it to you, but I won't waste your time. It doesn't matter which one we do first. Do we need any placeholders? No. Okay, but if we graphed it and it worked, what does our remainder have to be? 0. Otherwise, we did something wrong when we were doing the division, right? Okay, bring this down, multiply, add, multiply, add. Did I do that right? It did work, didn't it? Did someone else get that? Okay, then what? Successive division. I have to use the 4 into the leftovers. If I go back into it into the original, I'm not going to keep factoring it down. Bring down the 1. I have 4, 0. What's 4 times 0 on a good day? 0. Well, a lot of times students will do 4 times 0 is 4, or 4 times 0 is 1, or crazy business. Okay, What do we have, guys? It says irreducible factors. So part A would list what as the factors? X plus 6, x minus 4, and I don't have room. Let's see if I move it down here. What are the other? What's left? Yes, does everybody see down here where we're getting that? X squared plus 9. Okay, does that factor further? So that's the answer to A. B says we have to do linear factors. I kind of like to find C first. If you set that one equal to 0, x squared plus 9 equals 0, we'd get x squared equals negative 9. When we square root both sides, we get what? Plus or minus the square root of negative 9, which is 3i. So the zeros are negative 6, positive 4, 3i, and negative 3i, which you could just list as plus or minus. I'm fine with that. Anybody ready to tackle part B? Are you lost or you're... Okay. Part B is not as bad as it seems, guys. You just have to list it as linear factors. So you have to factor this, even though it seems like it doesn't factor. If we look up here, it's going to factor x plus 6, x minus 4, and what are the other two? Yes, 3i and minus 3i. All right, so this is called irreducible quadratic factor. This is linear factors where you've got them down into i's and you found the zeros. Do it in any order that makes sense to you. I liked writing out the zeros before I tried to write the linear factors. All right, let's try another one. Okay, I did it for you on the calculator, guys. This is what it looks like. Now, look what I did, though. I couldn't tell where it was crossing. Negative 3 worked, but I guessed negative 1. Would you have guessed negative 1? But I tested it. It says at negative 1, it's 100. Because I used a really big scale here. See this? So negative 1 didn't work. What did work was negative 1.25. Okay. So what do you want to start? It is negative 5/4. But what do you want to start with? We have to divide this bad boy out. The negative 3. Okay. I need someone with a calculator in hand. Because I don't want to try to do this by myself. I can bring down a 4. I can even multiply and get negative 12. Add and get negative 27. Multiply and get 81. 124 times negative 3. Added to 577 times negative 3 is negative 615. We did good. Okay, but now what do we have to use? Yeah, and we could just use the decimal. Okay. Calculator in hand. Bring down the 4. What's negative 1.25 times 4? Okay, add is negative 32 times negative 1.25. Add is 164 times negative 1.25. Yay. Okay. So far we have what? X plus 3 and x plus 1.25. And this. What is this? I'm going to write it over here because is that irreducible? What can we take out of all that? A 4? So if I take a 4 out, what's left? I put the 4 way out front here. X squared minus 8x plus 41, yes? Does anybody see why the 4, what happened here? Could we distribute the 4 through here? 4x plus 5. This will become 4x plus 5 if you distribute it through there, but I don't care. Are these irreducible factors? Which is choice what? Or part, is it A? Okay, there's the answer to A. It's not the only answer because we could multiply that 4 through here, but they're irreducible. Okay, before we try B, I want to go with C, which is find all the zeros. We have -3. We have -1.25. What do we have to do here? Quadratic formula? 8 plus or minus the square root of 64 minus 4ac over 2a. All right, I need help. -1. Oh, that's nice. Oops. Oh. It's -100. Let me write that better. Yeah, 8 plus or minus. I knew what you meant. Thank you. So it's 8 plus or minus 10i over 2. Everybody okay? What's that going to become? 4 plus, yes, 4 plus or minus 5i. So we got the zeros. How are we going to list out the linear factors? We have to have that 4 somewhere that we put out front, or we have to distribute it through one or the other. So 4x plus 3, x plus 1.25, and then this is going to be what? It's okay with me, guys, if you write x minus parenthesis 4 plus 5i, and then x minus 4 minus 5i. If you want to distribute and get rid of those inside parentheses, that's fine, but I don't really care. But those are the linear factors. All right. That's sort of terrible. Okay. This is the assignment, guys. 2, 3, 9, 11, 15, 35, 37, 43. This, guys, I can't stress enough. This is the assignment that if you don't do, you're not going to do well on this on the quiz. Because we don't have 3 days to warm up and practice this, right? Okay. I will tell you, I did not, guys, I did not put one that had that. The one that's on the quiz is like it has 1, -4, and 2i. So what's the other 0 you're missing? -2i. And that's not so hard to foil together, right? I didn't put one where it's like 3 plus 5i and 3 minus 5i, okay? What's the deal here? Why is it doing this?